We finished chapter 2 last week and did some practice questions. In this video, we're going to study three previous SOA questions from the textbook. Basically, our textbook is on the somehow introductory level to financial mathematics. That being said, the practice questions will give you a basic idea of the difficulty you will be facing in exams. And occasionally, there are a few SOA questions which are slightly more difficult, but I would say they are manageable. And I will put maybe 10% of SOA level questions on each exam. So that is the reason why I make this video to go through these three questions. The first one is 2.18. Let's read the question together. A perpetuity immediate pays X dollars per year. Brian receives the first N payments, Corinne receives the next N payments, and Jeff receives the remaining payments. Brian's share of the present value of the original perpetuity is 40%. Jeff's share is K, and we want to know the value of K, which is in percentage. So basically, we want to know what is the percentage of what Jeff will receive to the total perpetuity. As always, what I would ask you to do is to draw a timeline. It's a perpetuity, so the payments will never stop. It will just continue. And we know here we have first N payments. Each one, the size is X. So the first N payments will be collected by Brian. Okay, and we know the number of payments is N. Starting N plus 1, Colin will receive the payments of this perpetuity until, obviously, this should be 2N, because Corinne also receives N payments. So this belongs to Corinne. Okay, so both have N payments. So the first two people each will receive 10 payments. Okay, but obviously they receive those payments at different times. Starting 2N plus 1, Jeff will collect this amount and forever. So this will be collected by Jeff, so infinite. So what Jeff receives is a deferred perpetuity. Well, you can call it perpetuity immediate, right? Because he receives by the end of the year 2N plus 1, okay? And it's obviously a perpetuity. And we want to know the what is the percentage of Jeff's share. So first, we have one information. The only information we have is that Brian's share is worth 40%. 40% of the original perpetuity immediate. First of all, we know for perpetuity immediate, this is the present value. A stands for present value, and since it's immediate, so you don't put dot, you don't put bar. Here we have a perpetuity, so it's not n angle, it's an infinity angle. Here, using the formula, we know the present value of a perpetuity immediate is just 1 over I, and I is the annual effective interest rate. Okay, what we know? We know, by the way, we can simply set this payment to be 1 because it doesn't matter. It's a level annuity, it's a level perpetuity. each payment has the same size, so it will be canceled on both sides. So we can simply set the amount to be 1. Now what we have, the only information we have is that Brian's share. What is Brian's share? Brian received the first N payments. So basically to Brian, what he gets, it's an annuity immediate, right? With N payments. So basically this is what Brian receives. So to Brian, his present value will be A angle N at I. Okay. Here, of course, we assume the interest rate is the same. So we know his present value will be 40% of the entire perpetuity, right? Okay, so this is the equation. So now we start to put in the formula we have. That means on the reference side, I'm going to write down the present value of annuity immediate. So it will be 1 minus b to the nth divided by I. On the right-hand side, it will be 40% of my perpetuity immediate. Okay, so obviously, so let me use a different color to close this denominator. They can be crossed out, and by moving to the other hand side, what I get? I know the discounting factor over n years will be 60%. So now so basically that is the only condition we have. Now we're going to use this condition to study what is Jeff's share. Okay, so here Jeff will receive a deferred annuity, deferred perpetuity. So to Jeff, it is a deferred by 2n years. So, and it's perpetuity, right? So this is the notation. This means it is deferred by 2n years. Okay, and this obviously means it's a perpetuity. Okay, A stands for the present value of annuity immediate, right? So if you have an annuity due, you put double dots. This is for due. If you have continuously payable, so this is continuously payable. Okay, you put bar over your A. Okay, once we have figured out the notation, what do we have? This one will be deferred. You basically times by the discount factor. You discount by 2n years. So it's v to the power of 2n times this annuity. Okay, so basically what we are looking for is this, right? Because this one is nothing but the entire annuity, and this is just the K. So that is something we are trying to study. So now what is K? K is v to the power of 2n. It will be v to the n and then square. We already know the discount factor, so we just need to take the square, so give you 36%. So that is the answer you are looking for. There is a different method to do this. So here we have 3 people sharing the entire perpetuity. We know Brian's share is 40%, and we want to know Jeff's share. If we are able to compute the Colin's share, we should be able to know Jeff's share as well, right? So now let's analyze what Colin will receive. So let's analyze the second person. So what Colin will receive is the n payments starting from n plus 1 to n. Okay, so you can think this as a deferred annuity immediate. Okay, so if I'm going to write down what Corwin will receive, it will be deferred by n years. So this is Corwin's share. That is her present value. So she will receive an annuity, but deferred by n years. Okay. So since it's a deferred annuity, so we need to discount by the deferral period, which is n years. Okay. So now what do we have? This part is the same as Brian's share, right? This is a standard annuity. So if we go back to the timeline, what Brian and Corwin will receive is the same, except they will receive at different times. So Brian will receive his first payment at time 1. Corwin will receive hers at time n plus 1. So basically for each one, it will be an additional discount factor v to the nth, right? And we know, what is this? We know the discount factor is 60%. And we also know the Brian's share is 40% of the total perpetuity. So let's put down the perpetuity formula or the notation. So a simple math shows that this will be 24% times the value of the perpetuity. So Corwin's share will be 24% of the entire perpetuity. So what would be the Jeff's share? Will be 1 minus Brian minus Colin. So it's 64. 1 minus 64 is 36. So of course, right, we expect the same answer from 2 different methods. Now let's move on to do the next one. This question is actually very straightforward. What you actually need is a financial calculator. Let me put it here. So what you need is just a financial calculator. So you are allowed to bring in a financial calculator for all the exams of this course. For exam 1, it is not exactly necessary, or you have to, to get a financial calculator, but it will definitely help you. Okay. I think I already put an announcement on the financial calculator. To me, I don't want you to rely too much on the financial calculator. I would rather, at least I help you to truly understand everything behind different kinds of annuities before you use the financial calculator. So now let's study this question. The present value of the following 3 annuities are equal. So basically, we know they have the same present value, but they are different annuities. The first one is a perpetuity immediate, paying $1. So this is the easiest case. We already started this in the previous question. So this is the present value. Okay. Let me write down the notation first, because notations are also important. So this is the notation for perpetuity immediate. And we know the present value is 1 divided by I. And here the interest rate is 7.25%. So you can calculate the present value. An easy one, you can get the value is about 13.7931. When you have the calculator, you don't need to get this number. You can just keep this. What is the second one? It is a 50-year annuity immediate, also paying $1. So it's an annuity immediate. So it's A angle 50. The interest rate is actually at J. So that is the formula. Okay. So we know this is equal to 1 over 7.25%. Okay. Here J is something unknown. So you know the unit payment, which is 1. You know the term of this annuity, which is 50. you know the present value, which is on the right-hand side, then you can actually calculate the interest rate. So if I write down, it will be, here's 1 plus j to negative 50 divided by j. That is why I mentioned you probably want a financial calculator for this particular question, because this involves an equation that is non-linear. Okay, so you don't have any analytical method to solve for j. So you need some numerical methods to kick in to get you j. So if you have a financial calculator, you can punch in all the numbers. You will get j should be 7%. By the way, I do not ask you this type of question on exams. Okay, if I ask you for j, I will not ask you for a specific number. It will be something you can actually calculate using a standard calculator. So something you use even from elementary school. So this kind of calculator will do the job. Okay. But for SOA exams, you probably want to get a calculator approved by SOA. There are several choices. Might be seven approved calculators. Go to the website I provided. Okay, and now is probably the time for you to purchase one, since the first exam is coming. Once we know the interest rate J is 7%, we can move on to study the third annuity, which is an N-year annuity immediate paying, okay, still paying $1. But now what we don't know is the term. So now it's AN, but we already know the interest rate, right? So it's J minus 1, so it will be 6%. And here what we have will be 1 minus 1.06 to negative n divided by 0.06. Of course, all of them have the same present value, so I know what I equate to on the right-hand side. From here, it's rather simple, right? So what you need to do is to times 0.6 to the other hand side. So let me show you everything. So this is the original equation we have, okay? Then times by the denominator. So by the way, you can cancel the percentage. Okay, then move this to the left-hand side and then move the negative 1 to the right-hand side, okay? So still they are the same equation. If you want, you can do some calculation on the left-hand side. It will give you 1.25 divided by 7.25. Okay, now it's time for me to take a logarithm on both hand sides. So take a log. Okay, and because this is a log function, so the power term will come to the front. Okay, finally I divide by negative the log number, I get n. N will be negative the log 1.25 divided by 7.25 and then divided by log 1.06. The number is about 30%. That's why I mentioned for the second step, you probably need a financial calculator to get the result. But for the last one, you can use any calculator once you know the interest rate is 6%. So you may wonder, what if I don't have a calculator, right? In one of the examples, I showed you how you can apply trial and error to study this type of question. Let's say you can try J equals 5%. Okay, then you will find the number is too big. Okay, then if the number is too big, you want to increase your interest rate because the present value is a decreasing function of your interest rate, which means the higher the interest rate, the lower the present value. So if you plug in 5% and you found the value is bigger than 13.7931, then you should try a bigger interest rate, right? Then you will see it is still bigger. Then you go to the next one. Okay, then it's good. Then you stop, right? So that's the second SOA question. Let's move on to the last one. 2.20 to accumulate $8,000 at the end of 3 years. Deposits of $96 are made at the end of each of the first N years, and 196 at the end of each of the next 2 years. So timeline always helps. 1, 2 goes all the way to N. All the payments or all the deposits are made at the end of the year. So I know here I'm going to deposit $96. Here, $96, or 98, not 96. Goes all the way for the first N years. So here I made my first N payments. Starting at N plus 1, I will double my deposit. So the amount is 196. And plus 2, I have my second 196 goes until 3N. So this is when I make my last deposit. So here I have 2N payments of 196. Okay, what do we know? We know at this point the value of this account is worth of $8,000. So basically, that is the goal, right? I'm trying to make this kind of deposits, right? All of those, you can think this as a inflow to the account. By the end of 3 years, we want to accumulate $8,000. Okay, so let's analyze what we have done here. So for the, remember, 8,000 is at time 3N, okay? So when we study the first N payments, that's an annuity immediate, okay? And what do we want? It's you can either study the present value or future value, as long as you know what is the time point. So if you study present value, the value is at time 0. So for this, it will be 96 times A N at I, okay? But however, if you want to study future value, it will be at the end of this annuity. So it will be at AN. This will be 98 times S angle N at I, okay? Either one will be fine, okay? From this to the final point, you will need to accumulate for 2N years. So we are going to apply accumulated value factor for 2N years. Say that's how I accumulate, right? From time N years to time 3N years. So I have done the first part. So basically what I've done here is to convert the first N payments to time 3N, okay? Now I'm going to take care of the next 2N payments. Let's use this brown color. Okay, so the amount I already know. So if you want to use present value, the present value will be at the starting point. Okay, so this is 196 A 2N at I. Okay, so again, when I refer to the beginning of this special annuity with 2N payments, which goes from the end of N plus 1 to the end of 3N. Okay, I have 2N payments. But if I want to study the future value, it will be at the end of this annuity, which with as 196 S angle 2N at I. Okay, so since I want everything to be at time 3N years, so I use its future value. Finally, everything equal to 8,000. Okay, so let's review what's on the left hand side. Right hand side is simply the value of 8,000. Again, we should convert to time 3n. So that is the key point. We know at the end of 3n years, this account should accumulate $8,000. That explains the right-hand side. To accumulate to this amount, we apply two different annuities. Okay, the first one starts at 1 and at n. So I calculate the future value. The future value is evaluated at time n. In order to go from time n to time 3n, I times by this accumulation factor. For the second annuity, it ends at 3n. So if I look at its future value, it's directly at 3n. Okay. So now the question is to solve this. We should know the formula for the future value. It is 1 plus I to the nth minus 1 divided by I. This is 1 plus I to n plus 196. So this one, everything's the same except the term is 2n. Okay, so this is the equation we have. What do we know? We know 1 plus 2, 1 plus n, 1 plus I to the nth is 2. So now we start to plug in everything. 98 times 2 minus 1 divided by I. This is 2 square, so you get 4 plus 196 times 4 minus 1 divided by I equals 8,000. So apparently you can easily solve for I, which is, so here is 98 times by 4 plus 196 times by 3, okay, divided by 8,000. So it's an easy calculation. You will get the interest rate is about 12.25%. Basically, this is a standard way of solving this type of question. There are many different interpretations of this cash flows. So let me give you another one. Let's go back to, let's say, use blue color. So this time I do it slightly faster. Okay, we know here is 98, goes all the way to 98. Okay, starting from this time, the payment increases to 196, so it's double. But I don't write it as 196. I write it as 298. Of course, when you add them, it's exactly what we have. All right. So at this moment, you probably see the point why I'm doing this, because, okay, here I have two annuities. The first one, okay, the green one is annuity with 3n payments. Each payment is of size $98. So what is the future value? Right? Okay, now I have another annuity which has term 2n years, but the same payment. Right? So if I think this way, I actually don't need to do any accumulation, because for both annuities, they end at time 3n. And when we study, or when we use the notation S, it denotes the value at the end, right? So it's the accumulation value is always at the end of your product. Here we have the annuity. So for both, it ends at, for both annuities, they end at time 3n. So this is actually easier in this method, right? So if you don't believe, you can move everything. So now what we have is 1 plus I to 3n minus 1 divided by I plus 1 plus I to 2n minus 1 divided by I. So I can directly move 98 to the other hand side, right? So I know this is 2, so raise 2 cubic, so it's 8, so it's 7 plus 4, so it's 3, right? So this is actually easier than the other one, right? Because here we simply get 10 over I equals 8,000 divided by 96. So you get the same result. I will be, so it's right. So you will get the same result. Okay. Of course, they are the same because this is 98 times by 2. So when I fact out 98, what I get? 4 plus 6. So it's 10. So that's why I mentioned it is the same result. But it looks like method 2 is slightly better than method 1. Method 1 is the standard one because that tends to be what most people think when they say the change of annuities. They tend to think the first N, they tend to think the first N as an annuity, the next 2N as another annuity. But you don't have to, right? It's really up to you to decompose. I mean, it does not end here. I mean, you can even have more than I can give you another idea. So how about we sync all the payments of 196? Okay, obviously that's not correct for the first N because for the first N I only make deposit of 98. So we actually borrow extra. So we need to put minus for the first N. Right? Now, how do we analyze? For this one, it is very easy to analyze. We know this is nothing but 196 S3N at I plus, okay, not plus, minus 98. This is an annuity, so let's do its future value. I have N of them. Okay, it's not down. Let me write down so you can see it in a better way. Minus 98 S angle N at I. Okay, but when I use this annuity, the future value is at this time point, right? It's not at 3N, so I will need to times by this to the end point equals 8,000. Okay, please check. You will get the same result. So basically, when you study annuity questions, the actual method may differ, but you should get the same result. I will stop here, and that marks the end of chapter 2.